Welcome back guys, my name is Akshay and today we are going to learn how to use eSim-FreeEDA software to simulate various VLSI circuits. In this video, we will take an example of 2-input NOR gate using CMos inverter. The above one is the circuit diagram which we will design now and the below one is the output which we will observe. So let's get started. So, right click on the eSim software and click Open. Now create a new project and give it a name. In my case, it is this one. Now click on the first block of the 8 blocks to open the schematic wherein we will create a circuit diagram. Now this will give you a warning that no schematic has been created yet. Do you wish to create one? Click on Yes. Proceeding further, we will now have to add our components in this schematic. To do this, there is an option given Place a component on the right of the screen. Click on it and a list of components will be appearing. So in our case, our circuit diagram needs 2 NMOSes which are to be connected in series, 2 PMOSes which are to be connected in parallel, 3 DC source, 3 power supply, blah blah blah. All the list of components which are used in this circuit are given in the description. Note that while searching the components, the names of the components differ according to the software version. Now I will fast forward this video and will come back after placing all the components. If you want to move any component, simply right click on it and click on Move Component or Drag Component. And if you want to rotate any of the components, then click on Orient Component and rotate as you like. Now we have finished placing our components and it's time to wire them. To wire the components, there is again an option given on the right of the screen and is Place a wire. Select that option and start wiring. To wire a component, click on the terminal of the component where you want to start wire and drag it to the point where you want to connect. So we have completed connecting all the wires and we can see that one connection is still open. We will move ahead and we'll see what happens next. The next step after wiring is to annotate the schematic. To do this, go to Tools option and click on Annotate Schematic. Now select the first option for the first 4 multiple choice questions and select the second option for this dialog term. And then click on Annotate. Now it's time to check the errors in this circuit. To do that, again go to Tools and click on Electric Tools Checker and then click on Run option. Now it is showing an error that pin is not connected. Remember that in our circuit one connection was still open, and now to connect the wire simply double click on this error and it will show you which connection is still open. Now again choose the option place a wire and do the necessary connections. Now further making changes, we will again have to annotate the schematic. To do this, again go to Tools and click on Annotate Schematic and then click on Annotate. After that, we will again perform electric rules check, and this time there should not be any error in our circuit. Now it's time to give a reference variable to the three DC sources, capacitors and resistors if used. Giving a reference variable is important because it helps in identification between the three DC sources, or else we can't distinguish them if the names of the three DC sources are same. So to assign a reference variable to any component, simply right click on it and then select edit component and choose reference. Here for the DC source 1, we give the reference variable as V1 and reference variable as V2 and V3 for the remaining two DC sources. And now we have to give the voltage values to these three DC sources. In 2-input NOR gate using CMos inverter, we keep DC source V1 as variable and the DC source V2 and V3 to the voltage levels of 5V and 10V respectively. So now to assign a voltage value to these DC sources, again right click on that component and select edit component and then choose value. And now we again annotate this schematic. Remember that annotation is the information given to the eSim software about the components used and also the reference value assigned to these components. So if any further changes made after the previous annotations, then we will have to again annotate this schematic, or else it will give an error in the later stages. And now it is time to generate Netlist. Netlist gives the information about the connections done in the components. So to generate a netlist, again go to Tools and then click on Generate Netlist File. Now in this Files tab, select the default format and then click on Generate Netlist. And then click on Save. And now here we complete the work of the first block that we have selected from the 8 blocks. And we select second block of the 8 blocks in which the DC source V1 will be varied. The DC source V2 and V3 will not be varied because they were kept constant in previous stages. We will vary the DC source V1 from 0 to 10 volts by the incrementation of 1 volts. And then click on Add Simulation Data. And then click on File in the upper left corner and save the simulation data. Saving of the simulation data is very important. So please make sure that you have saved the simulation data. And now we select the third block, which is the netlist converter. Here it says that add parameters for DC source V1. As DC source is varying from 0 to 10 volts, we will keep the DC source V1 as 0 volts as it is the starting point of the variation. And it also says as add parameters for DC source V3.
So we entered 10 volts as it was kept constant in the earlier stages.
And then select submit and exit. And now finally click on the fourth block, which is the ngSpice. Here in the list of nodes, select CMos N and then click on plot. And so we have the final output. Thanks for watching, guys. Please like, comment and subscribe if you like my video. Thank you.